A couple things to remember when we're proving stuff. First, always get as much information as you can. Look at the diagram that you're given and look at the markings very carefully because it's pretty common that there's going to be some markings that tell you things are congruent. So look for those and write them down. The second thing is don't assume. Do not assume something is an angle bisector or that things are congruent. Just because they look congruent does not mean that they are. We've been talking about that a lot. So it has to be marked or you have to be told. We are proving that DBA, that's this bigger one, DBA, and you don't have this, it didn't print right. So can you please add this to your paper? D should be right here. E should be right there. You need to mark that on your paper. Otherwise, these notes aren't going to make a whole lot of sense when you look back at them later. Because you're going to be like, where's D? Where's the E? I don't know. I don't see it. Add it in. All right. We're proving that those two angles are equal to one another. Okay. We start by saying what's given to us. So we're making a two-column proof with statements and reasons. Just like you did yesterday with the algebra proofs. Now we're going to take up every single bit of space, so don't write too big. Look at your picture and figure out what is given to you. So look at the picture, look for some markings that could tell you something. Can you please discuss that with your partner? There's something happening. What has been marked for you? Could someone raise your hand and tell me? They are! Oh, look at those little arcs that you see. So these little arcs tell you congruent. And so you know that measure of angle 1 is equal to measure of angle 3 because of those little markings. So that's the first thing we're going to write. I would avoid using the congruent symbol for now. It's a lot easier to work with equals. We'll get to congruence later. So measure of angle 1 equals measure of angle 3 because of the marking. It was given. I know it didn't say it specifically, but if it's marked for you, that counts as a given. Now, I get pretty disorganized, and so I like to draw a line. Okay, that's one thing. If you have more than one givens, you can put them all in the same spot, all in the same row. So we need to write some equations, because we're dealing with algebraic type of proofs. We need to write some equations that include DBA and EBC. Angle 2 plus measure of angle 3 would be equal to what? DBA, right? We're trying to create an equation that has DBA in it, and so we're going to add up the two parts that make up DBA. So I'm going to say measure of angle 3 first, if that's okay with you. Measure of angle 3 plus measure of angle 2 is equal to the measure of angle DBA. Part plus part equals the whole. Look at the picture. 2 plus 3 would give you the bigger angle that they're a part of. Nice, Tori. So again, part plus part equals whole. And why are we allowed to say that? You guys are saying part plus part equals whole. What's the name? Sam? Yes, you have to say the reason, right? Angle, addition, postulate. What you're doing is explaining to someone why you're allowed to say those things. Good. So we said two things in the same line. That's allowed. You can say angle, addition, postulate for both of them. Need some ideas on how to make the equations look exactly the same. Obviously, DBA and EBC are still going to be different, but that's okay. So, Aubrey, what do you think?
We said the substitution property because angle 1 is equal to angle 3, so then you should substitute angle 1 for angle 3.
Yeah. So you have this statement up here. Measure of angle 1 is equal to measure of angle 3. And she's saying that you can substitute that. Which equation are you going to substitute in? Okay, bottom one. We can substitute 3 for 1 right here. Or you could do it to the other equation, because you know that 1 is equal to 3. So I can replace and make them look the exact same, because when they look the exact same, when their equations are the same, that means they're equal to one another. So let's go ahead and do that substitution. So instead of putting measure of angle 1, Aubrey, what am I gonna put? Right? So measure of angle 3 plus measure of angle 2 is equal to the measure of angle EBC. I'm going to highlight that again so you see it. So we substituted right there for measure of angle 1. We replaced it with measure of angle 3. So our reason that we put to the right is the substitution property of equality. Look at the proof and see, can we say now that DBA is equal to EBC? Okay, could someone explain to me why am I allowed to say they're equal now? Brennan? Look at the equations for DBA and our new equation for EBC. What do you notice, Brennan? So because they have this in common, measure of angle 3 plus measure of angle 2, you can say they're equal to each other. And I would take, you could say transitive, or you could say symmetric. Either one, no, not symmetric. You could say transitive or substitution. Either one is good with me. So measure of angle 2, oh my goodness, measure of angle DBA, we were struggling, is equal to the measure of angle EBC because of substitution, or you could say transitive because they have that middle thing in common. I can't. I'm trying to put guys, I can't spell today. Substitution. Whew, okay. So in your next proof, you are proving that PZ is equal to SM. So we start with saying statements on the left, reasons on the right. And we look for what's been given to us. That's the first thing we look for. So can you please look at the diagram and see what has been given to you? So because of your markings, you say this. They're both marked congruent. And we say it's given to you by the picture. So we can say PS plus SZ is equal to PZ. Bonnie, why are you saying that? What's the property or postulate that allows you to say that? Awesome. I can do part plus part equals a whole. Okay, we can make one more equation. Sophia? Okay, so I'll say ZM plus SZ equals SM. Segment addition postulate, we can say that those two smaller parts equal the whole. Cool. You could do the same type of thing we did last time and substitute. And that would be perfectly fine, but we just did one like that. And so I'm going to do this one a different way. So you could substitute for ZM and then say they're equal to each other. That would be a perfectly acceptable way to do this proof. But I'm going to do it a different way. I'm going to say that SZ is equal to SZ. What property is that? Reflexive. If I'm saying that the thing is equal to itself, it's because of reflexive. I'm saying that because I'm about to add it to both sides of our first equation. So in order to add it to both sides, I have to say, hey, those two things are equal before I do it to both sides. Okay, the first equation we had was PZ is equal to, sorry, wrong letter. PS is equal to ZM. I'm going to add SZ to both sides of that. So I'm going to say PS plus SZ equals ZM plus SZ. So I'm taking SZ and adding it to both sides. I'm allowed to do that because we just said that they are equal to one another. Look back over the proof. We said PS plus SZ equals ZM plus SZ. Where else do you see those two expressions? Postulate. Right up here, we said those same two things. And so instead of writing the longer way, we're going to sum it up and give our final answer. Oh, whoops, did I forget to put a property? We did this one because of the addition property of equality. We added the same thing to both sides. I am now allowed to say the final thing, which is PZ equals SM because of the substitution property of equality. Because if you look, we said PZ is equal to PS plus SZ, and SM is equal to ZM plus SZ. That's what we have in the equation right before we set our answer.